Hello and welcome to this video on our two density kits. On my right is the density shapes kit, and in front of me is the density cubes kit. Together these two kits form the perfect basis for not only exploring density, but also geometry, fractions and partitioning, and even understanding volume and mass of different geometric primitives. More than that, you can take the data that you're collecting and then graph it and analyze the graphs for even things as high as linear regression. Let's talk about what the two different kits have. In the density cubes kit, we have 9 cubes, and although the 3 shapes look identical, due to the unique benefits of 3D printing, we're able to control how much plastic is actually inside each cube. Which means when students take 3 seemingly identical cubes and drop them in the water, they're going to behave in 3 very different ways. As you can see, the hollow one floats, the solid one sunk very quickly, and the one that was in between took its time to sink. Now this is something that the students can hypothesize about in advance, whether or not they think the objects will float prior to dropping them into the water. And so students can take a scale, they can weigh the objects and compare to the density of water to then see if the object that they have here should float or sink. And if it doesn't quite work out the way they'd expect, they can provide explanations for why that might be. Is the temperature of the water right? Is the salinity perfect? Is this pure water, or could it be influenced by other things such as fluoride? With the density shapes kit, we're bringing in more of the math side of things. So not only are you getting a chance to discuss density, and students can make hypotheses about whether the big one or the small one will sink or float, or whether they'll both behave the same way. And most students, without feeling them at least, probably wouldn't guess that the big one will float while the small one sinks. But that is what happens because the big one is hollow and the small one is solid. So you can have some fun with this at the front of the classroom before you distribute them to the students, and let them have their own tubs too to explore and play with to see if the objects behave the way they would expect them to. But with this one, it's really more focused on calculating the volume of 3-dimensional shapes, using that volume and then the calculated mass of the objects by placing them on the scale and comparing what 2 halves versus 1 whole looks like, to realize not only that the mass of the objects, when fully combined, has not changed, even if it comes in 3 parts. It's not going to be perfectly precise, but that's a good chance to also discuss with your students some of the measurement error, some of the differences in 3D printing, and although these have been optimized to be as close to perfect as possible, every single brand of filament, every color, every spool, all weighs a little bit different. So if you want these to be perfectly precise, you might want to do some tests and trials before you pass them out to the students. But when you do have them, the students can get a really interesting look at the law of conservation of math as well, and so you get the chance there to see and do the math to realize that even though this cube's been split in half, its overall density has not changed. More than that, you can take both of these kits and do some really interesting graphing activities. So you might decide to compare surface area to volume, or the mass of the object to its density, and look for patterns and look for the different curves and the different lines that you get. Up in high school, you can do linear regression with these, and then you can even integrate it more on the science side to see what your data does or how it changes if you affect different things. How much would you have to change the water temperature for it to make an impact? What if you affected the salinity? How much salt do you think it would take to make a difference in the water content in terms of these middle ones here floating or sinking? And if your students really want a challenge, you can challenge them with getting the water just right for these 3 centered ones to be neutrally buoyant. It takes a lot of salt typically, but it is possible. So to do that, you'll have to do some trial and error, probably with your specific printer, trying different densities of the infill amount. To adjust the infill yourself, simply turn off one-click printing, and then under infill, you can adjust the density up and down until you've optimized it for your water and your filament. So however you're using this, whether in elementary school you are simply comparing and classifying objects based on their attributes, so you might do small and large and use comparison terms. You might talk about partitioning and that you've partitioned this cylinder into 2 equal parts, or now you've partitioned it into 3 equal parts. So from elementary school all the way up to high school, there are activities that you can do with your students that are going to surprise them, intrigue them, and get them really interested in the math and science that's going on. We hope you enjoy using them, and we can't wait to see all the great things your students will learn with these 2 kits.